Hi you guys, this is Miss Pruitt, and I wanted to make a video tonight about what we talked about in class today, which was vertical asymptotes. Vertical asymptotes, here are some things that are true about vertical asymptotes. Number one, if f of x is approaching positive or negative infinity, as x approaches c from the left or the right, then x equals c must be a vertical asymptote. 2. If a function has a vertical asymptote, then it is not continuous. It's one of those discontinuities that we talked about the other day. And number 3, a vertical asymptote occurs whenever the denominator equals 0. There is not a common factor that will cancel out, and the numerator is not equal to 0. So let's hop right in and start doing some examples. On this screen, I'm only going to focus on solving for number 1. So, find the vertical asymptotes. I find vertical asymptotes by setting my denominator equal to 0. It's as simple as that. In this case, I'll have x plus 5 equals 0. If I subtract 5 from both sides, I get that I have a vertical asymptote at x equals negative 5, and that is the answer for number 1. For this screen, I'm going to focus on number 2. And I have t squared minus 4 divided by t squared plus 5t plus 6. Well, before I do anything, I'm going to see if I can, what I can factor and if I can factor. I see that my numerator is a difference of squares. So that factors out to t minus 2, t plus 2. And my denominator, I have a trinomial. Trinomials factor down to 2 parentheses. When you're factoring a trinomial, what's your first step? Just like we do in class. First step, parentheses. Second step, your variable. In this case, they're t's, not x's. Third step are your signs. You always look to the right. If it's a plus sign, that means your 2 signs inside the parentheses are going to be the same. What same are they going to be? That's when you have to look to the left. They're going to be plus signs. All right? Then we do a times c. In this case, a times c is 6. And then we list the different things we can multiply together to give us 6. In this case, 1 times 6, 2 times 3. What 2 things, if I multiply them together, I'll get 6. But if I added them together, I would get 5. Of course, it is 2 and 3. After I plug these in, now I've factored my numerator and my denominator. I check and see what I have. And I see that t plus 2 cancels out. That leaves me with t minus 2 over t plus 3. Got some stuff mixed up there. T plus 3. So I'm looking for my vertical asymptote. Whatever I have left in my denominator, which is this, I'm going to set it equal to 0. So if t plus 3 equals 0, that must mean I must have a vertical asymptote at t equals negative 3. And that is the answer. By the way, because we canceled out the t plus 2, we actually have a removable discontinuity or a hole in the graph at t equals negative 2. Okay, last number 3. Well, focusing on this one. I see what I can factor out in my numerator. I can't factor anything out, but I can factor my denominator because that is a difference of squares. It is x plus 3, x minus 3. And again, you have a vertical asymptote wherever your denominator is equal to 0. So I set both of these equal to 0. That means I will have a vertical asymptote at x equals plus or minus 3. And that will be my answer. Next, this is a sample free response question. It says, let f be the function by f of x equals x divided by the square root of x squared minus 4. It first wants us to find the domain of f, then write an equation for each vertical and horizontal asymptote to the graph of f. So I know my rules. To see what my domain is, I ask myself, first, is it a fraction? Well, yes. 2, is it a square root? In this case, yes, to both. And 3, is it a logarithm? No, it's not a log, so I don't have to worry about that. But I have restrictions on my domain, so instead of it being all real numbers, I cannot have a 0 in my denominator, and I cannot have a negative value underneath my square root. The only thing that satisfies both of those conditions would mean that x squared minus 4 must be greater than 0. Cannot be greater than or equal to, even though you can normally have a 0 underneath the square root. So I do x squared minus 4 is greater than 0. This is a difference of squares. That means x minus 2 and x plus 2 must be greater than 0. But to check where my domain truly is, I need to look at the number line. Let's say that this is negative 2 and this is positive 2. I'm going to pick values on both sides of positive and negative 2 to check exactly where my domain is. So I'm going to check up for a number over here. Let's say negative 3. If I were to plug in a negative 3, would I get a positive number or a number that is greater than 0? So let's see, I would get 9 minus 4, which is a positive number. I'm actually going to erase this. Positive number, so that checks out. Let's pick a number that's in between negative 2 and 2. An easy one, of course, is 0. If I were to plug in a 0 for x, I would get 0 minus 4, which is negative 4, which means I will have a negative underneath my square root. So no, that doesn't check out. But if I were to pick a number on the right-hand side of 2, let's say 3 again, this time 3, not negative 3, I would again get 9 minus 4, which would be a positive number. So that checks out. So my domain will actually be negative infinity to negative 2 united with 2 to positive infinity. If I were using set builder notation, I would say all real numbers except x must be less than negative 2 and x must be greater than 2. So either one. The question still asks, so all of this is part A. Part B. I'm going to erase, give myself a little bit of room. So part B asks for the equations for the vertical and the horizontal asymptotes. Well, we already found where x cannot exist in our denominator, and that was at plus or minus 2. So for my horizontal asymptote, I would say they are located at x equals plus or minus 2. Let's talk about the horizontal asymptote. We talked about it a little bit in class today. As you can see from my equation, I got x over the square root of x squared minus 4. Now I'm going to ignore this 4 for a moment and just look at what I have here with the x over the square root of x squared. Well, just analyzing it, I don't want to lose you, I could say that this is like x to the degree of 1. And really, the square root of x squared would also be x to the degree of 1. And because we talked about Bobo, Betsy, and Bo 2, this would be a Betsy, where the bottom equals the top as far as degrees are concerned. So then we look at the coefficients in the front. That's why the horizontal asymptote will be located at y equals 1. Last but not least, this is our last problem. It's f of x equals 9x squared minus 36 divided by x squared minus 9. We want to describe the symmetry of the graph and write an equation for the vertical and horizontal asymptote. Well, if I factor, so let's start with A, of course. If I factor the numerator and the denominator, let's see, I can pull out a 9. That will leave me with x squared minus 4 over x squared minus 9. And both the numerator and the denominator have a difference of squares. So this would be x minus 2, x plus 2 over x minus 3, x plus 3. Said 3, wrote 2. And as you notice, nothing actually cancels out. This does end up being a very symmetrical graph, though. I'll end up with having intercepts at positive and negative 2, as well as having vertical asymptotes at positive and negative 3. And the graph will follow a path that looks similar to this. Uh-oh. I said similar. Not identical. Similar to that. So I just discussed just the symmetry of the graph around actually the y-axis. So now let's talk about B, the vertical and horizontal asymptotes. With the vertical asymptote, of course, you set the denominator equal to 0. And you solve. This will be x squared equals 9. Take the square root of both sides. I don't want the algebra 1 answer. I want my algebra 2 answer, actually, where x equals plus or minus 3. Hopefully your algebra 2 teacher focused on the fact that if you're taking the square root of a variable, that your answer could be positive or negative. So I will have vertical asymptotes that live there. We kind of already talked about that in part A. And then to find, okay, vertical asymptotes. And so then to find our horizontal asymptotes, we do Bobo, Betsy, or Bo2. In this case, the degree of my numerator is the same as my degree in my denominator. So if the bottom equals the top, you look at the coefficients. Remember, there's an invisible 1 right there. So I have a horizontal asymptote at y equals 1. And that's it.